Hello everybody, and greetings from the Delta College Planetarium. My name is Brian, and I'm here to bring you the next episode in our series exploring the constellations. Last time we used the bright star Vega to help find the constellation Hercules. This time we return to Vega to find another constellation. In the summer, Vega is high in the sky after sunset. If you look at Vega for any length of time, you will likely recognize that there are two other bright stars in this region of the sky. Taken together with Vega, these stars form a really nice, almost isosceles triangle. Because that triangle is high in the sky during the summer, we call it the summer triangle. Each of the stars in the summer triangle is the brightest star in its own constellation. Today we're going to look at the bright star on the short leg from Vega. This star is named Deneb. And Deneb appears to sit in a line of 4 stars. And another line of 4 stars crosses that line at the second star. This shape is called the Northern Cross because it kind of looks like a cross and is visible from the northern hemisphere. But this is actually just a portion of the constellation Cygnus, the swan. Deneb is the swan's tail feathers. The body stretches down and the swan's wide wings branch off to the sides. The swan's long neck extends to its head in the center of the summer triangle. Deneb is an interesting star. At magnitude 1.25, it looks noticeably dimmer than magnitude 0 Vega. However, Vega is only about 25 light-years from Earth. Deneb is about 2,500 light-years from Earth. This means that even though Deneb appears dimmer in the sky, it produces something like 5,000 times more light than Vega does. The head of Cygnus is a fun star to look at through a small telescope. This star is named Albireo, and a small telescope will show that it's actually 2 stars. What is so striking about the component stars is their color. Albireo A is the yellow star, and is the closer of the two. Albireo B is the blue star. Because the stars are so close in the telescope, our eyes have a better ability to detect the color, and Albireo is a very popular target for amateur stargazers. It's unclear at this time if Albireo A and B are a visual double or are a binary system. Many measurements have been taken of the 2 stars, but the evidence remains inconclusive, unable to rule either scenario out. Cygnus also has the distinction of having been studied for a considerable time by the Kepler Space Telescope. Kepler was a NASA mission to observe the luminosity of stars very precisely and over a long period of time. The hope was that by watching these stars uninterrupted, a telescope could detect if the star's light dimmed for a period of time. Analyzing that dip, we might be able to tell if the light from that star was being blocked, perhaps by a planet passing in front of it. Using this method, the Kepler Space Telescope confirmed the presence of more than 2,600 planets orbiting around other stars, and nearly as many as yet unconfirmed planet candidates. Almost all of these observations were made as Kepler stared at a small patch of sky in Cygnus. Each of the markers here represents another star with at least one planet known to orbit around it. The beam you see is the result of the Kepler observations. Cygnus was chosen because it lies in a direction of a dense part of the Milky Way, so there would be a lot of stars to observe there. But there's nothing particularly special about those stars, no reason why they should have more planets or have planets more frequently than any other group of stars in the sky. In fact, we should be led to believe that planets are plentiful throughout the galaxy. Current statistical evidence suggests that there is at least as many planets in the galaxy as there are stars, something like 200 billion planets. Of those, something like 10 to 40 billion planets should be Earth-sized. If your goal is to find a second Earth, looking at all these planetary systems can feel like searching for a needle in a haystack. But I want to impress upon you just how rapid our understanding of planets in our galaxy is progressing. 30 years ago, we didn't even know if the haystack existed. So if it's clear where you are tonight, go out and look for the summer triangle. and trace out Cygnus the swan, and consider, for just a moment, the multitude of worlds that populate our skies, and the wonders and mysteries each of them must hold. That's it for today. Next time we'll examine the final corner of the Summer Triangle. This is Brian from the Delta College Planetarium, wishing you clear skies.